Hey, this is Mr. Perez. Today we're going to talk about real numbers, but let's get Charlie out. He better be ready to go. Hey, Charlie, ready to go? All right. Today we're going to talk about real numbers. All right. Let's put our real number line up right there. There it is. Okay. Well, the first set of numbers we're going to talk about within the real numbers is the natural numbers. And those are basically the numbers we count on our fingers, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? You can go on forever and ever up to positive infinity. And so let's go ahead and label our real number line with those natural numbers. There they are. Now, the next set of numbers we're going to talk about are the whole numbers. The whole numbers just brings in the zero, right? The zero makes it whole. And so whole numbers bring in the zero on our number line. And within the set of whole numbers, obviously, are the natural numbers, right? Now, our next set of numbers are called the integers. Now, the integers, Charlie, bring in the negative numbers. Those are the bad numbers. They're not the bad numbers. Those are the good numbers. Be quiet over there, Charlie. All right, let's go ahead and put our negative numbers on our real number line. And there they are right there. So the integers are the set of numbers that we mark our real number line with. Okay? And within the set of integers are the whole numbers and obviously the natural numbers. Well, what about in between the markings on the number line? Those are the fractional values. And that set that includes the fractions are called the rational numbers, right? The rational numbers include the fractions, and those are values that will fall somewhere in between these integer values that are marked on the real number line, right? And so rational numbers, again, are the fractions. Well, aside from the rational numbers, within the real number system are the irrational numbers, and these are not fractions. And we'll talk about those in a second here. Okay, for now, let's focus on rational numbers. Now, within the set of rational numbers are these integers, the whole numbers, and the natural numbers. Rational numbers, as I said, are basically fractions. For instance, the fraction 4/3. 4 divided by 3, which means 1 1/3. It's the mixed number 1 1/3. That would be 1 1/3. So it would fall somewhere between the 1 and the 2 over there, right? Okay. And so the rational number 8/4. Okay. 8/4 means 8 divided by 4. If you take 8 divided by 4 in your calculator, hit your equal sign, you'll get 2. So 8 divided by 4 is a rational number, but it represents number 2, which is a natural number. So the number 2 expressed as a rational number is 8/4, really expressing it as a fraction. Okay? So now let's talk a little bit about irrational numbers. Irrational numbers, I said, are not fractions. They are numbers like square roots. Like the square root of 2 is an irrational number. Well, how do we know if we're looking at an irrational number or a rational number? Well, we have to look at the decimal representation of the number. For example, let's talk about rational numbers, which are the fractions. All fractions will have decimal representations that do one of two things. Either the decimal representation will terminate, which means it'll stop, or the decimal representation will go on forever and ever and ever, but there's a pattern to it. For instance, if you take 3/4, which means 3 divided by 4, take a calculator out and hit 3, hit your division sign, and then the 4, and then the equals, you'll see a decimal representation of 0.75. Notice the decimal stops. It terminates. 3/4 has a decimal representation that terminates. Now, let's try 13/11. That's a fraction, right? And put in 13, hit your division sign, enter 11 and hit equals. Now look at its decimal representation. It does go on forever and ever and ever, but you'll see a pattern to it. It goes 1.18181818 forever, right? And so when we write that decimal representation down, we put 1.18 and we put a bar over the 1.8 to tell us that it's repeating. So all fractions will have decimal representations that either terminate or go on for an ever and ever and ever with a pattern to it. And that's what we call rational numbers. Now the irrational numbers have decimal representations that go on forever and there is no pattern. For instance, take out your calculator and take the square root of 2. you'll see a decimal representation that goes on forever and ever and ever. Another famous number that's irrational is called pi. It shows up in many different applications of mathematics, and that's considered a irrational number. You cannot represent it as a fraction. Okay, so together, the rational numbers and irrational numbers make up the real number system. So within the set of real numbers are the rationals and the irrationals, right? And within the rationals are all these other groups, integers, whole numbers, and natural numbers. Okay, so let's look at some actual numbers here. Let's define some rational numbers and some irrational numbers. So let's look at 13/11ths, and if you did take a calculator out, you would see it's 1.181818, so it lies over there somewhere a little bit past the 1. 13/11ths as a mixed number is 1 and 2/11ths, right? 1 and 2/11ths, so it's about over there. -3/4. Well, -3 divided by 4 is a -0.75, and so that's like a -3/4. It would be right there on the number line. -0.25. Okay, that's -25/100ths. It's the same as -1/4, which would be right there between the 0 and -1. Now 1.2373737. Notice the bars there because it's telling you the decimal representation goes on forever and ever, but there's a pattern to it. And it's obviously 1.237, so it would be somewhere between the 1 and 2 as indicated there. -2 1/3. Well, -2 1/3, it's right over here, right? Negative number between the -2 and the -3. Okay, now the irrational numbers. If you have a scientific calculator, you should have a pi key, and you press that key, and it'll give you this long decimal representation with no pattern. It's about 3.14159, and it goes on forever. It's a little bit bigger than 3. Take square root of 7. You'll see a decimal representation that goes on forever and ever and ever, and there's no pattern to it. And notice we put the squiggly equal sign there because it can only be approximated, because there's no way for us to write the entire decimal representation down because there's no pattern to it, and it goes on forever and ever and ever, right? And so that's why we say it's approximately equal to 2.64575, and we can mark it right there. Same with square root of 3. Remember, negative square root of 3 means take the square root of 3 and multiply by -1, which gives you negative 1.73205. That's rounded there, and so it would be somewhere over here. And finally, 2 square roots of 5. Now, 2 square roots of 5 means 2 times the square root of 5. And so you have to realize you must follow the order of operations, which we talked about previously, that you first got to do the grouping symbol. That means you got to calculate the square root of 5 first, and then multiply by 2. And when you do that, you should get about 4.47214, which is about over there. So there we go. So that's a little talk about the real number system. I hope you enjoyed that, and we'll see you again soon.